Good morning, friends. This is the first question that we are going to take today. The question is, after the block has moved 3 meters from rest, the constant force P is removed. How long will it continue to move in the same direction? Find the velocity of the block when it returns to its original position. So as you can see in the figure, there is an inclined plane having an angle of 30 degree and a block is resting having a weight of 100 newtons on it. The block is subject to an external force of P is equal to 150 newtons. The P force is acting parallel to the incline. Now what are we supposed to find in this case? The problem states that the force P is removed after it has traveled a distance of 3 meters, and after it has traveled a distance of 3 meters we have to find out how much further the block moves when the force P is removed. This is the first thing. And secondly, we have to find out velocity of the block when it returns to its original position. So we will solve this numerical into two parts. First we'll find out the distance moved by the block, and then secondly we'll find out the velocity when it comes to its original position. So let us first draw the free body diagram of this figure. So if you see here, this is the free body diagram of the given figure. So there is a inclined plane at an angle of 30 degree. This is the block. It is subjected to a force P is equal to 150 newtons. This is the weight of 100 newtons which is acting, and we have resolved the weight 100 into its two components, 100 sin 30 and 100 cos 30. Then force P is equal to 150 newtons is shown. Normal reaction perpendicular to the plane. Then under the action of force P is equal to 150 newtons, the block will have a tendency to move upwards. So that's why the motion of the block will be vertically along the plane, vertically upwards. So the force of friction here will be acting vertically downwards, which is equal to 0.2 times normal reaction. I hope you have understood the free body diagram. Now it says that after the block has moved a distance of 3 meters. So the block initially starts from this. So at this position the velocity v1 equal to 0 because the block is initially at rest. Then when the block has traveled a distance of 3 meters, the constant force P is removed. So at this point, this is the second position I am taking. So at this point the force P becomes equal to 0. So at this point there is no force P. So further from position 2, the force P is removed. So this problem, or this first statement, that is in which we have to find out the distance traveled by the block after the force P is removed, will be solved in two parts. So first we'll concentrate on position 1 and 2. So at this point the velocity v1 equal to 0. So when the block moves a distance of 3 meters, it will travel with certain velocity v2. So first we'll find out this velocity v2 with which the block travels a distance of 3 meters. Now to find out this, we have to again use work energy principle. From the work energy principle we can find out the velocity v2. So this is the equation of work energy principle. So we'll apply the work energy principle. Work done is equal to change in kinetic energy. So here it is 100 is the weight multiplied by sin 30 into distance traveled is 3 plus 150 is the normal reaction, I think, into 130. It is the external force P multiplied by distance of 3 meters minus because the force of friction is acting vertically downwards and it is along the negative direction of x-axis. Multiply the force of friction 0.2 times multiplied by 100 into cos 30 into 0.3. Why this cos 30 into 0.3? Because this is this force of friction normal reaction is nothing but equal to 100 sin 60 into 9.81, or if you can find out the normal reaction as summation of f of y, take summation of f of y equal to 0. From this we can write down n1 minus 100 cos 30 is equal to 0. So we get n1 is equal to certain value. That is what we have written here. So from this we can get the value of n1. Now after we get the value of n1, this whole equation, so we have calculated the work done considering the force of 100 newtons, sine component of weight multiplied by distance 3, then P force multiplied by distance 3, and then the force of friction multiplied by distance 3. I have written here 100 cos 30 into 3. 0.2 is the coefficient of friction. This is equal to half times, it is what? half mv square, so it is half multiplied by 100 divided by 9.81, because it is mass, so w is the weight, so we will divide the weight by the 9.81 to convert it into mass, multiplied by this final velocity is v2 minus v1. Here 0 is nothing but v1, where v1 is equal to 0. So when we solve this, we get v2 is equal to 6.976 meter per second. So what we have solved is, the block was here, so in a distance of 3 meters the block moves with a velocity of v2, where we get v2 is equal to 6.976 meter per second. So this is only the first part of the distance moved by the block after it has moved 3 meters. Now we will find out how much is the distance the block moves after it travels, after the force P is removed. So after this point, from point 2 to 3, let us say that the block moves a distance of d1 up to position number 3. Now the block will continue to move until its velocity becomes equal to 0. When its velocity becomes equal to 0, the block will come to rest. So whatever is the momentum gained by the block, when the force P is equal to 150 newtons is applied, so due to that momentum the block is moving upwards, and at a distance of 3 meters the force P is equal to P is 0, because the force P is removed. So after this the distance is d1, so the block moves the distance of d1. So now we will apply work energy principle between position 2 and 3. Initially we had applied between position number 1 and 2. Now we are going to apply between position number 2 and 3. So at this point the velocity v2 is equal to what? So what is the initial velocity now? v2, which we have already found. v2 is equal to how much? 6.976. Now we will apply work energy principle to position 2 and 3 to find out what is the distance moved by the block. Again, all the factors remain same, only the value of P is become equal to 0. The block is again moving upwards, so the weight will be acting vertically downwards. Now what is the distance? Distance will be equal to d1, and what is the velocity? Initial velocity will be v2 and final velocity will be v3. So again we'll apply the work energy principle to this block. So it is equal to minus, I have written d1 here, you can take it as s also, d1 equal to s in the new while writing this equation I have written d1 equal to s, so we can take d1 as equal to s also. So here the block is moving vertically downwards, so the equation will become minus 100 into sine 30 into distance is now s, minus force of friction, that is minus 0.2 into 100 cos 30 into distance is again s. There is no P force, so the P term will not be considered here. This is equal to half mv square. V square means half 100 by 9.81 m into final velocity is v3 minus initial velocity is v2. So when we solve this equation, we get displacement s equal to 3.684 meters is the value. So after the block has moved a distance of 3 meters, further the block moves a distance of 3.684 meters. So this is the first part of the question, in which we have to find out the distance moved by the block after the force P is removed. So after the force P is removed, initially the block moves a distance of 3 meters and then it moves a distance of s, which we have found out by using work energy principle. So first we have applied work energy principle between position 1 and 2 to find out the velocity v2, because distance was known to us. And in the second part what we have done is velocity v2 was known to us, we have found out the velocity v2, and then distance d was unknown, or distance s was unknown, and the block moves till its velocity becomes equal to 0. So we also know the final velocity, and we are applying the work energy principle between position 2 and 3, and we have got the value of distance. So in the first part velocity was not known, distance was known, and in the second part velocity is known and we have found out the distance. So this is the first part, this completes the first one. I hope this is clear. Now we'll move to the second part. In the second part what we are supposed to find out is the velocity with which the block comes to its initial position. Now what is the total distance traveled by the box from its initial position? So total distance traveled by the block from its initial position is, say, x. What is x equal to? X is equal to 3 plus s. So it is equal to 3 plus, we have got this value as 3.684 meters. So the total distance the block moves is equal to how much? 6.684 meters is the total distance the block moves. Now the block is here. Now the block is here. Now it is returning to its initial position. So initial position is here. So the total distance the block has to move is 6.684 meters. Now we have to find out that the block is here. From this position the block is coming over to this initial position. So we know the distance and we have to find out the velocity with which the block moves. So I have drawn the free body diagram here. Now this is the free body diagram. Now the block is here. The block is here. So the block is having a weight of 100 newtons. It is subjected to a horizontal component of 100 sine 30, vertical component of weight 100 cos 30, and then normal reaction N1. Then the block is moving, the motion of the block is downwards, so the force of friction will be definitely acting upwards. There is no force P. Now the total distance the block has travelled is how much? It is equal to S equal to 6.684 meters, the total distance. Now this is your position number 1 and this is your position number 2. We are applying the work energy principle from position 1 to position 2 now. Again, by taking summation of f of y equal to 0, we will get n1 equal to 100 cos 30. Now the block is here, initially it is at rest, so velocity here v1 will be equal to 0, and then we have to find out the velocity with which the block comes to its initial position. Now we know the distance, we have to find out velocity. So either or will be required. So either distance is given, then you have to find out velocity, or velocity is given, you have to find out distance. Now we will apply work energy principle to this. So this is work done is equal to change in kinetic energy again. So first we'll consider weight. It is moving downwards. It is 100 sine 13 to minus 6.684. I have taken both of them positive. Why? This is moving downwards, so this will become negative. Displacement is also become negative. So negative into negative will become positive. So this entire term will become positive. Minus coefficient force of friction is acting upwards. So this will become plus. But displacement is downwards. So this entire term will become negative. This is equal to half mv square. So initial velocity is v1, final velocity is v2. So from this, when we solve this entire equation, we get velocity v2 equal to 6.546 meter per second. So the block comes to its initial position with a velocity of 6.546 meter per second. I hope this is clear.